Hello, welcome to eCHO episode 105. And today we have Philip Nikolic. And Philip is going to be walking us through a very interesting topic today. He's going to be talking about CNIs from like first principles up. So I'll just give the floor to Philip to like introduce himself and then tell us what he has in store for us today.
Absolutely. Thanks so much, Paul. Yeah, as you already mentioned, we're just going to look at the basics of CNI, right? Oftentimes we cover here on eCHO a lot of advanced and complex topics, right? We're having all sorts of things like network configuration, encryption, all kinds of BPF stuff, right? And so it really can be a bit complicated for people starting out, or as well thinking like, oh, all of this, it's kind of like dark magic and whatnot. So we really want to go away as well from that perspective and really show that all of the things that a CNI, such as Cilium, is doing is actually just a sequence of very logical steps, right? And so what I would like to talk about today is just to make sure that people understand that a bit better so that it doesn't seem like a black box anymore, but really to have a rather basic understanding of what a CNI is actually supposed to do. And so this is now not only something that happens to Cilium or how Cilium is doing things. This is basically what every CNI out there does, right? So we're really going to take a look at the basic functionality here. We're not going to cover any specific Cilium topics or BPF topics here. It's really just taking a step back and just looking at the basic principles. Does that sound good?
Sounds good. We're looking forward to it.
Amazing. So let me start by sharing my screen. I have a couple of slides prepared here that are going to help us understand a bit more of what I'm talking about. So here, we should be able to see my screen. Is that right?
Yes.
Yeah, amazing. So on this slide here, I did a couple of talks already with this topic. I always like to call them demystifying and then a certain topic. In this particular case, demystifying CNI. And as well, I like to do this by writing a CNI from scratch. So as already previously mentioned, my name is Philip Nikolic, and I work at Finland, which is now part of Cisco. So for today, we really want to cover what is CNI. Oftentimes when people hear the word CNI, they do actually think of projects such as Cilium, right? Technically, however, Cilium is not a CNI. We will get into this in a bit. There actually is only one CNI that truly exists, and that's the project that you can see on the left-hand side. So CNI stands for Container Network Interface. And the important aspect here is that the project on the left is specifying what a CNI is supposed to do, what these kind of things, these kind of container network interface plugins, we call them, are supposed to do. So Cilium is actually not a CNI, if we're very pedantically about it, but rather what it is doing is it is implementing the CNI spec of the other project. And so if this didn't confuse you enough, this is how the project looks like, right? The CNI project, it's I think it's an incubating right now, a CNCF incubating project. And so it is a GitHub project on its own. You can see there it has a couple of explanations, what is a CNI and so on. But the important aspect you can look at here is the link at the bottom where it says specification. If we were to look into this specification, it is essentially just a very or rather long document specifying exactly what you're supposed to do and how you're supposed to do certain things in order to be compliant with this specification of a CNI. And so all the things that you usually think about are following those. Now, if I didn't lose you so far, perhaps it would be easier to do this with some pictures, right? So when we think about how a CNI works and what exactly it does, just think about a user sending some kind of pod YAML over, right? A user wants to have the best application ever running on a Kubernetes node, right? So they're sending that over to the Kube API server. And now at the Kube API server, from the API server, there's going to be a lot of communication going back and forth between other components of Kubernetes, right? At a certain point, the scheduler, the Kube scheduler, is actually going to choose a node and be like, hey, this is the node where this pod is supposed to run. So the API server will then reach out to the kubelet on that specific node, which is kind of handling all sorts of Kubernetes-related things on that specific node. And many people then assume that kubelet actually is going to create and run these containers, but that's not really the case. Kubelet just has a lot of helpers, let's call them that way, lots of helpers that are going to do the work for it. And so in this particular instance, the kubelet is going to send over the request to the CRI, the container runtime interface, which is going to create the container for us. And then we will have a CNI that is going to configure the networking aspect of that specific container. So far, so simple, but oftentimes where the confusion comes into place is actually that this is not really the CNI, as previously mentioned, but rather it is the CNI plugin that is supposed to do these things. The CNI itself, the actual CNI, is basically this thing in the middle. It is the thing in the middle that specifies exactly how this communication is supposed to happen. However, since the community simply likes a lot of abbreviations and it is just very pedantically about speaking of, oh, are we talking about plugin? Are we talking about the actual definition of that communication or not? Oftentimes the community just refers to it as the CNI, which is as well what you'll see here on my next slide, since it's just what people are used to. But I just want really to talk about this for a second here, because it is something that if you really dive into this topic a bit more, it may be a bit confusing if you hear the word plugging coming up here and there, but this is essentially what it means. So the goal that I would like to focus on for today is to give people an understanding of the following. When you send over that pod spec to the API server, it lands to the kubelet, the container runtime is going to create something for you. It is actually going to create something called the network namespace. Now, in case people are not really familiar with what that means, namespace doesn't really have anything to do in this context with the Kubernetes namespaces that people oftentimes hear about, right? In Kubernetes, you have those namespaces, just coincidentally the same name. The namespace in this context is actually referring to Linux namespaces. They're a kernel technology, a Linux kernel technology that is basically used for isolation. That's how the kernel is documenting them. You have to be a bit careful with that word, with the word isolation, because it's not doing as much isolation as, for example, a virtual machine does. However, the important aspect is there is different kind of namespaces that you can have, and containers consist of these namespaces. And what is important for us is that container runtime is going to create such a network namespace, which means an isolated networking environment. So we can do something in that namespace. We can do network changes in that namespace without it affecting the node or other kinds of network namespaces out there. That's really the idea. So for all sorts of Linux namespaces that exist, you create one, and you will be able to go ahead and change things in there, mutate them without affecting other namespaces out there. And this already is kind of one of the key principles how containers work. So the container runtime is going to configure this, and there is way more as to what exactly the container runtime can do. In case people are interested in how exactly that works, I have something similar prepared as well for container runtime interface itself. You can find it on GitHub if you want to, but I'm not really going to focus on that much more than this. So what we're going to focus on here is the CNI aspect. So after the network namespace has been created by container runtime, it is going to call our CNI. And what we're then going to do is essentially we're going to put in special interfaces in there in order to ensure that network configuration is properly established for that container. And so this is the job of CNI. Everything that we go further and beyond to do these things is basically just a layer of additional complexity that we can add on there. But in its simplest and purest form, this is essentially what we're supposed to do as a CNI. Obviously, with Cilium and so on, we can do much more than this. But again, just want to take a step back and really show you the key principle of what a CNI is supposed to do. And there is no real magic involved here. We'll go through all of these steps one by one in order to show you how exactly that works. And we'll do this on a one-node cluster because it's simpler, obviously, than doing it in a multi-node cluster. But maybe we can talk about this at the end as well. So that's our goal. To summarize as well a bit, again, what exactly is going on here? So we have CNI and we have CNI plugin. The CNI is the API between the container runtime and the CNI plugin, and it's a CNCF project on its own. You can find it on GitHub, container networking/CNI. The CNI plugin is usually what people are referring to, what people are talking about, talk about various CNIs such as Cilium. And so it is the software responsible for the container network configuration. And it's the thing that receives the tasks from the container runtime, and it is implementing the CNI. However, to not always go back and forth and confuse people further, I'm just going to stick with the word CNI from now on. So if we look at this from a step-to-step perspective now, how exactly do we achieve what I showed before to have this kind of working network configuration inside a container? This is where we really need to dive into this CNI spec. It is defining a couple of things of how this communication is supposed to happen. And now we're going to look into as well what we are going to do and how we're going to do it. So after the network namespace was created, the CRI is now going to contact the CNI. And the question is, how does it do this? Well, there is two important paths on a file system that we need to know about here. The first one being /etc/cni/net.d. In there, it will then look for the very first file that it can find, which is as well why we usually see something like a prefix for files in that particular directory. So in my case, you can see that I called it 10-demystifying.conf. The 10- is important because if you had multiple files in there, it would simply go ahead and choose the very first one, which is why you see this prefix quite often. So we will have to create a file in that directory, and we'll have to make sure that it's going to be listed as the first one. And then we'll put in a JSON in there. So this already where we begin to where we need to have some sort of understanding of what exactly CNI is. It is basically saying, hey, these are the things how this JSON needs to look like, right? So we have this configuration file there that is JSON, and we can put way more things in there than just what is shown here. But to have a very minimalistic approach to things, this is all we need for now. So we define their CNI version. This is the version of the CNI spec. So there's different kinds of versions as things evolve, right? There's always going to be certain additional features that come on later and so on. And in order for the container runtime and the CNI plugin to be able to really communicate with each other properly, you will have to just pinpoint, hey, I am talking about this version. Do you implement it, yes or no? So this is what that is for. Then we have a name, which we can pretty much arbitrarily choose anything we want. It's not really that important in our use case here. And what is important, however, that I want to highlight is the type. What we can see here for the type is that I put it to demystifying. Now, what exactly does this do? Well, whatever we put here as the type, in our case, demystifying, is going to be very important for the next step because it is now going to take that as the name of an executable that it is going to search for. So in the next step, it is now going to look in another path on the file system, and it's going to check whether this is now something that you can find there. So in /opt/CNI/bin, it is now going to look for an executable called demystifying. And please note, what's important here is that I use the word executable. So it does not really have to be a binary. It does not have to be certain Go program or whatever. Oftentimes we have this understanding that everything related to Kubernetes nowadays has to be written in Go, right? But this is actually not the case. And as well, to prove that this is not the case, what we're going to do is we're going to write our own CNI actually in Bash, just to prove that it's not necessary for you to know about Go or to code Go in order to get things up and running in Kubernetes. So we're going to have there an executable called demystify. And this means as well, you will need to modify it in such a way that you can just, like any other Bash shell script, whatever you want to use, being able over shell to invoke it. And so when we do this, we can as well pass over certain environment variables, which is what we see here as well. So it is invoking that executable. It has environment variables that it passes on there, such as CNI command, CNI netns, CNI IF name, and we'll get back to these in just a bit. So these are some of the environment variables it's passing on. It can also pass on something over the std_in, the standard input. However, we're not going to focus on that. So the very first thing that we now want to do when our executable is being executed is we want to create a so-called virtual Ethernet pair. Now, for those not familiar with what exactly that means, essentially they're very special interface types. They always come in pairs. So you will have two of them and they're, so to speak, connected. And the idea is the following. Whatever traffic you send to one end of them, the kernel is automatically going to forward to the other end. Now, admittedly, this may seem a bit redundant right now, like why would you want to do this? But we'll get in a bit why this is important to us and why we need this functionality when we're working with containers. So for now, what's important is there is this virtual Ethernet interfaces that we need to create. So the question now arises, obviously, let's do this step by step. How do we do this? How can we achieve something like this? And so since I already mentioned we're going to do this in Bash, we're going to use a lot of times the IP command. The IP command is very powerful and it allows us to tinker around with the networking aspect of things quite a bit. So with the IP command, we can execute IP link add in order to add another type of device, in order to add another interface. And so then we'll just say that we want to name it veth_host. And we'll define that the type is a VF, a virtual Ethernet pair. As I mentioned, they always come in pairs, which as well means that we'll have to create a peer. And so the peer we are going to name veth_netns for now. So after doing this, we've created that one. We've created the virtual Ethernet pair consisting of two interfaces as shown here. Now, the next thing that we want to do is we want to take one of them and move it inside of the network namespace that was previously created for us by the container runtime. So how can we achieve this? Well, again, we can use the IP command. And in order to now reference the network namespace, this is where these environment variables come in handy. So there's a lot of information being passed through to us via environment variables. It's not just a couple of things we see here, it's usually way more, but these are the things that are necessary for us right now. So we'll have an environment variable called CNI underscore netns there, and it will tell us which network namespace we are supposed to perform our configuration on. So if we now do this IP link set vf underscore netns, it means we want to take that specific interface with that name, and now we want to move it to the network namespace called CNI minus FB37 and so on, which obviously I just shortened out here. It usually is way longer than that, but that's what's important for us. Here is that we're moving it in there. This is, so to speak, the name, the identifier of that network namespace, so that we can do this. So why did we want to do this? Well, because as you can see here now, we now have one interface inside of the network namespace, and the other one is still residing on the node, on the host itself. The host itself also has a network namespace. We usually refer to it as host network namespace. So we now have the vf underscore host still being on the node, and the other one is inside of the network namespace that is designated for the container that we're going to create. So by doing this, we as well now have the possibility to send traffic to and from these two different namespaces, right? Because if you remember what I mentioned earlier about virtual Ethernet interfaces, is when you send traffic to one side of it, the kernel is going to forward it to the other. And so this is now how things can traverse through them. However, we are not done yet, because we still need to be able to configure things properly in order to have such a working traffic flow. So the next thing that we want to do is, obviously, we need to assign an IP address to that interface that we just moved. So what we are going to do here is we're just going to give it an IP address 10.244.0.20. Again, the question comes up, how exactly can we do this? Well, IP command to the rescue again. And since we're doing this inside of the network namespace, we will now use -n. Again, the -n just specifies what namespace we're talking about. It may seem a bit simplistic on this particular slide here, because we only have one network namespace here, right? But if you think about it, like a node usually has a lot of different pods there, right? Dozens of pods, hundreds of pods in theory that it could handle. And so you need to be able to specify exactly which network namespace you always want to perform configuration in, which is why we will have to address this all the time. So with IP -n, we're telling it inside of that network namespace. We now want to add the address 10.244.0.20 and do it for the device vf underscore netns. So far, so simple, right? And we're now going to do pretty much the same thing as well on the node side of things, where the other interface is on. And we'll assign that one an IP address as well, right? Simply chose here 0.101. It could have been something else as well if we want to, but that's the one I'm sticking with for now. The IP address that we assign to the interface inside of that container network namespace, this one is obviously always having to change, right? So we will now hard code it to 0.20 as we did before, but usually you would have this, you would have an IP pool where you can take an IP address from, and every pod would get its own IP address. But this is what we're stuck with for now. So the next thing we would then want to do is we'll go over and we'll rename the interface inside of the network namespace. So how do we do this? And again, there is another environment variable that helps us with this, because the container runtime can specify how it wants that interface to be named. So if we go in there and we check the environment variable CNI underscore IF name, which stands for interface name, we can see that it was set to Ethernet 0, which is usually the case. And we will now go ahead and use the IP command, again, specify the network namespace, link set, put in the name of what the interface was called so far, which is v@_netns, and then name Ethernet 0, right? So by doing this, we now successfully renamed the interface, and it's from now on called Ethernet 0. So if you've ever executed the IP command like an IPA inside of a container, you as well oftentimes will have seen that pretty much regardless of how many containers you have running on your system, the interfaces are always called the same. And this is exactly why. You can have always the same name because of this isolation that I talked about earlier, because network namespace basically isolate these things, right? So there is no overlap of things as long as you do it in their own dedicated namespaces. So what's next that we'll have to focus on here is now we need to understand how exactly can we get traffic to reach one of these interfaces. So what we will do here is the following. We'll have to add a routing entry, an entry inside of the routing table on the host side. And what it is doing is actually quite simple. All that we're saying is when there is traffic that wants to go to the destination 10.244.0.20, then go ahead and send it over the device, which is a synonym for interface, send it over the device vf_host. So what this will now achieve is whenever you want to reach inside of the network namespace, you are now telling the kernel, hey, please go ahead and send that traffic to the vf_host interface. And because of the way how virtual Ethernet pairs work, it is going to forward it to the other side, and it is able to reach inside of that network namespace. So how can we add this entry? Well, IP route add is going to help us there. And now we just specify what we already mentioned, 10.244.0.20/32 in order to make sure that it's really only if you want to reach that specific IP address. And then if that's the case, please send it over the device vf_host. Now you may think, oh, that's great. So that's basically it, right? We're done. Well, almost, because what we still have to do is as well make sure that traffic can come out of the network namespace, out of the container, right? So how exactly can we achieve this? In order to do that, we'll have to add 2 entries to the routing table inside of the network namespace. So again, network namespace own sort of isolation for network configuration, which means it has its own routing table. So one thing that we'll now have to do here as well is similar to what we did below, meaning that if you look at the second line, it will say anything that wants to go to 10.244.0.101, please send it over the device Ethernet 0, right? So if traffic from within the container wants to get out, you will have to send it by Ethernet 0 in order for the kernel to then forward it to the other interface so that it is available on the host system. But now the question is, so what if I want to communicate with something that is not that IP address? Let's say you would like to go to Cilium.io, right? Cilium.io doesn't have the IP address 10.244.0.101. It has a total different IP address that you will have to figure out somehow. So how would I reach these IP addresses? And so for this reason, we'll also have to add a default route in there. So basically what a default route does is it is saying, regardless of the IP address that you want to reach, this rule will apply to you if there is no other rule that is more specific. That's essentially the gist of a default route. So what we're saying is any IP address, that's what the default means, any IP address that's not otherwise specified, please send it via, and then we put in there the IP address of the interface that is residing on the host side, the 10.244.0.101, and send that over the Ethernet 0 device. So by doing this, we now ensure that if you want to reach Cilium.io, it is now knowing that, okay, even though that's a different IP address, I will make sure to send it to 0.101, and then it's checking, oh, how can I reach 0.101? And it will see, oh, I need to send it out Ethernet 0, because it sees that traffic is going from Ethernet 0, the kernel will go ahead and forward it down to the other interface. Hopefully that's clear. And after we've done all of that, we now have established proper connectivity between the network namespace as well as the host system. And so we can now go ahead and finish our things up. And so the CNI will now just have to send over a JSON back to the container runtime, informing it about what it did, such as which interfaces it created, how they're called, the MAC addresses they have, and so on. So as a result and as a recap, two important paths to look at. This is how it's going to look like. We'll have certain files in there, but I would like to now get away from the slides if possible and rather go over here. I have an entire repository where a lot of this is explained as well. So in case somebody's more up for reading things, parsing things, copying, pasting things, rather than looking through a video or slides, very happy to explore that repository. I'll share it at the end as well. It's GitHub f1ko/demystifying-CNI. We'll see the link afterwards again. It is pretty much written like a blog post, so you have an introduction. It is explaining a lot of these things that I already mentioned, has some pictures in there of what we're supposed to do, step 1, 2, 3, and so on. And as well, it has in there a make file that can help you to set up an environment for you to follow along and be able to tinker around with your own CNI and even take it a step further if you wanted to. So if we were to look at this, essentially what we're doing here is if you execute make, cluster, or create, or init, or set it, or start, whichever of these words that you want, it is going to use kind. It's going to use kind in order to create that cluster for you. There's a kind configuration in here that is very simple. It just says, hey, disable the default CNI, which means there will be no CNI installed. And it is therefore just going to give you a cluster without a CNI, which is great because it means you can now go ahead and create your own one in order to figure things out yourself. So when we do this, we will have a cluster in there, which I will do here, make init. Once we have that make init in there, we'll soon see that the cluster is being created and it's going to do some steps in there. And in the meantime, while it is doing that, let's look at the following files here. The first file, as I mentioned, is this very simplistic JSON. And we'll now have to take this JSON from the repository and copy it over to the node of the cluster. The CNI configuration, all of this stuff needs to happen on each and every node. So it's not just sufficient to have this running on one node. In case you were having a multi-node cluster, you would have to do this on every node. So this here is then the final bash script that I was referring to. And we'll get through it step by step together here. So the first line here is just ensuring for us that when we call it, it will know exactly how to interpret it, that it is supposed to run as a bash. Then we have what we mentioned. We will create a virtual Ethernet pair. This is how we're going to do it, exactly as we did in our step-to-step example. Then we'll go ahead and put one of these interfaces inside of the new network namespace. And the way how we do this is because, again, we have environment variables that are being passed to our script when it's being called. Then the next thing that we're going to do is we are going to hard code the IP address. I simply chose this to be 10.244.0.20, and we're going and assigning that IP address to the interface that we just moved inside of the network namespace. And then on the host side, we're as well going to assign it an IP address. Then we're going to rename it. We're going to ensure that everything is up and running. And then we are going to add the routes that we talked about inside of the network namespace. That's where we have 2 commands there. And then we'll have to add 1 route entry on the host side as well, which is why we have 1 command here. And then we have this JSON file here that I showed as well, where we're essentially just specifying what we did. Hey, this was the version that we understood and how we did things. Here are the interface that we did, right? We created 2 interfaces because virtual Ethernet interface come in pairs. So we're gonna take the name and the MAC address and the name and the MAC address and the sandbox. Sandbox essentially means this is what this network namespace oftentimes refer to, right? So in Kubernetes words, we refer to this as a sandbox. Oftentimes as well, you can hear something like pause. Yeah, this is essentially what it means. So to let it know in which namespace we did things, and then as well the IP addresses. We'll figure all of that out, just figuring the MAC address out, and then we're going to print the JSON via standard output, std out, and that's pretty much it. That's what we're gonna do. So let's check our cluster now. We should have everything up and running at this point. We can check what exactly there is in the cluster. It's a very simplistic cluster here. All we have is in kube system, just the things that are necessary for Kubernetes to work, which means like we have etcd, we have API server, controller manager, kube proxies, scheduler, and so on. At the end, we can talk a bit why these things are actually running, because they're pods running inside of Kubernetes, right? So how can pods actually run if there was no CNI installed so far? We can talk about this in a bit, but let's focus for now how we could get our application running. So the goal would be for us now to have this very simplistic test application running. So we'll create a pod called the best app ever, and this is what we want to have running in the end. So if we were to do this right now, it wouldn't work because the container runtime would go ahead and create it, would go ahead and try to create the container, but then it would call upon the CNI. There is no CNI yet, so it would fail. So what we now need to do is take our files here and copy them over to the node. And the way how we can do this is very simple. I have a target for this. We can call it make copy. So if I do this, it's going to copy everything over. It's just copying it over to that specific node. That's pretty much it. So now we basically have a functioning CNI on our node. And so now we can go ahead and perform our test. We could now go ahead and test it out, whether this test YAML that I showed previously is going to work. So we can run make test. All it's going to do, as you can see, is it's going to apply the test YAML. The pod has been created, and now it's going to perform a kubectl get pods -o wide. What the -o wide is doing is it allows us to see as well the IP address. And so we can see here that there now is a pod running called best app ever. It states running, ready 1 out of 1. It is 5 seconds old. It's running on this specific node, and it has the IP address 10.244.0.20, which is exactly the IP address that we hard-coded and set in our specific script here. So what we can then do as well is to check, does this really now work? Can we somehow perform this? Well, what task could we perform? So it is a very simple. Web server based on HTTP. Actually, it is HTTP D that is running inside there. So what we can do is just do a curl onto that IP address, and we can see the result is it works. And so this is how we can write our own CNI. Yeah, that's pretty much it. What we didn't do, however, is obviously we hard-coded a lot of this stuff here. So we have this IP address hard-coded here, which as well means we wouldn't be able to now have a lot of different applications running on there, right? And this is how we would advance things and how people can go further ahead and take this as a homework assignment if you want to, and have an entire IP pool in there in order for you to be able to create multiple things with different kind of IP addresses, because each and every pod is supposed to have an IP address on its own. You can as well think about, oh, how can I advance this a step further in order to ensure that multi-cluster configuration works, that multi-node configuration works, because this is a very simple one node cluster. As you can see here, just one node, that's it. And so how exactly can we go further and further to do all of these things? So yeah, hopefully that was helpful. And just to explain as well a bit of limitations of CNI, or not so much the limitation, but perhaps the wording of asterisks when a CNI is not being invoked, may be interesting to know. When we look at these pods that we had from the very beginning when the cluster was created, let's check them again. Get pods minus a white. You heard me say that usually every pod is supposed to have its own IP address, right? Which we can see here with best app ever having its own designated IP address, which was what we set in our script. So what about these pods here? They all have the exact same IP address, right? 228.4. How come? Well, the CNI does not do any kind of configuration for these. And the reason why is because these pods, all of these pods, let's take one as an example, get pods minus cube system. Let's, for example, take these etcd pod minus OYAML. You'll see in the YAML in there that there is something called host network. And that is set to true. So if you were to go ahead and set in a pod host network to true, what this means is that the container runtime is now not going to create an own designated sandbox for that pod, right? Sandbox is essentially this network namespace. Rather, what we're telling it to do is, hey, do not create its own one, rather use the one from the system that you're performing this on, which basically means there is no need to invoke the CNI in that case, because all the network configuration should already be done, since it is running directly in the host network namespace of the host. So this is a thing to think about, and this is how you can spin up still certain applications, even without a CNI, if you were to use host network. And with that being said, yeah, that's pretty much it. How people can build their own CNI.
Yeah, thank you very much, Philip. That was very insightful. I actually didn't know like some of the cluster components used like the network and namespace. So that was a very new one to me. Yes, this was a very interesting. I liked how you took your time to like structure um, everything. I was resisting the urge to ask you questions throughout like the, the entire time because I didn't want to interrupt your flow. I figured out like you had a flow ongoing. I didn't want to have you break it, but yeah, this was this was very interesting, and yeah, thanks to for everyone that came out and joined this session of our Echo episode. We look forward to seeing you in the next episode of Echo. You can always find the Cilium community on Slack. You can find us on social media, on LinkedIn, on Twitter. And if you have any questions about like this, you can always reach out on Slack. If you're curious, I can I can pull up a blog post. So Philip has a blog post about about the same topic he recently published. If you want to see that, you can. I'm just gonna post that on the comment now. I okay, I'm gonna. That's just give it a bit. I think that link is a bit. Yeah, that's a funny link. But yeah,
You're
you
fine.
can go on the main isovalent on the main isovalent website. There's a blog section on one of the nav bars. You can click there, and this is a very recent blog post, so you would see it among like one of the very first few blogs. And yeah, and thank you very much for coming. I look forward to seeing you in the next episode, and I look forward to hosting Philip another time. We had a very insightful sessions. I learned a lot about like network namespaces, CNI, the difference between a CNI and a CNI plugin, and how like making like that distinction very clear, and how it's easy to like mix up the both, and from very first principles how it's very actually writing an actual CNI. If you strip it down to like the basics, it's actually something that's very basic. It doesn't look like it's not complicated, because when you see Cilium has all these moving parts, and it feels like very exhausting. But if you actually look at it from like first principles, it's a very simple concept to get started with. So yeah, I want to ask you like a follow-up question. So when we started this session, you said something, and then you said Cilium is not it's not a CNI, and you're gonna get back to that in a bit. So I just want to follow up on that. Maybe you want to like just talk a bit more about that.
Absolutely. So, in essence, as I already mentioned, perhaps the easiest part would be for me to share the screen again quickly. Is in essence that all of these things, and by the way, here's the project where you can find the repository. It's here in the bottom right on GitHub f1ko/demystifying-CNI. There's as well, as previously mentioned, something similar, but without a write-up yet on the CRI as well. So what I wanted to show up here is that when I mentioned this, that Cilium technically is not a CNI and many of the other things are not, it's because this is the only CNI that exists. It is the CNI project itself. And so if we again think about the difference between what a CNI is and what a CNI plugin is, right? Essentially, what we oftentimes refer to as a CNI just means that it is implementing the CNI aspect of things. So it is adhering to this API standard that was set, and this is pretty much what I mean by that. So I know it's a bit confusing, and it's mainly about semantics here, but
Yeah. Yeah. Thank you very much, Philip. Happy to hear that you clarified that. I'm pretty sure like some people had like people also curious about that. Yes, we had a very insightful echo. This is our 155 episode, and thanks for coming around. I will see you in the next episode of Echo. Thank you.
thanks so much, Paul. Thank you for having me.
Bye.